Hello, everyone, and welcome to another episode where we explore the mysteries of the cosmos. Today, we're embarking on a journey through some of the most profound and fascinating theories about the origin and nature of our universe. From the enigmatic beginnings of the Big Bang to the mind-bending possibilities of the multiverse, we'll navigate the frontiers of modern cosmology and physics. Let's begin with the cornerstone of cosmological theories, the Big Bang. According to this theory, approximately 14 billion years ago, the universe emerged from an extremely hot and dense state known as a singularity. This singularity was a point of infinite density and temperature where the laws of physics as we know them break down. The universe then rapidly expanded and cooled, leading to the formation of fundamental particles, atoms, stars, galaxies, and eventually life itself. However, the Big Bang theory, while widely accepted, leaves us with some profound questions, especially concerning that initial singularity. What exactly happened at the very beginning? What existed before the Big Bang, if anything? This is where our current understanding reaches its limits, and scientists have proposed various theories to fill in the gaps. One such theory is string theory, a leading candidate for a theory of everything. String theory posits that the fundamental constituents of the universe are not zero-dimensional point particles, but tiny one-dimensional strings. These strings vibrate at specific frequencies, and their different modes of vibration manifest as the various particles and forces we observe. In essence, all matter and energy are the harmonious vibrations of these fundamental strings. String theory also introduces the concept of extra dimensions beyond the familiar 3 dimensions of space and 1 of time. Some versions of the theory suggest there could be up to 10 or even 11 dimensions. These additional dimensions are compactified or hidden from our perception, curled up at scales smaller than atoms. Building on this, the idea of brains emerges. A brain is a multi-dimensional object within string theory. Our universe could be a 3-dimensional brain floating in a higher dimensional space, sometimes referred to as the bulk. In this framework, it's conceivable that there are other brains, other universes parallel to ours. This leads us to the concept of the multiverse. The multiverse theory suggests that our universe is just one of potentially countless others, each with its own physical laws and constants. As physicist and author Brian Greene writes in The Hidden Reality, our universe may be one bubble in a grand cosmic bubble bath of universes. This idea challenges our traditional notions of uniqueness and raises intriguing possibilities about the nature of reality. Another perspective on the universe's origin comes from quantum mechanics, particularly the concept of quantum fluctuations. In the quantum realm, empty space isn't truly empty. Instead, it's a seething backdrop where particles and antiparticles constantly appear and disappear. Some theories propose that the entire universe could have originated from a quantum fluctuation within a primordial vacuum. Physicist Lawrence Krauss discusses this in his book, A Universe from Nothing, where he explains how the laws of quantum mechanics allow for the spontaneous creation of particles and even entire universes from nothing. Moving forward, let's consider the current state of the universe's expansion. Observations of distant supernovae and the cosmic microwave background radiation have revealed that not only is the universe expanding, but this expansion is accelerating. This unexpected acceleration is attributed to a mysterious force known as dark energy. Dark energy is thought to make up about 70% of the total energy content of the universe, yet its true nature remains one of the biggest enigmas in modern physics. The discovery of dark energy has profound implications for the ultimate fate of the cosmos. If the acceleration continues unchecked, the universe may keep expanding forever, leading to a big freeze or heat death, where galaxies drift apart, stars burn out, and entropy reaches a maximum. Alternatively, some models propose a big rip, where the expansion eventually becomes so extreme that it tears apart galaxies, stars, planets, and even atomic structures. Conversely, if dark energy were to change over time, an idea proposed in theories involving quintessence, the expansion might slow down or reverse, culminating in a big crunch. In this scenario, the universe could collapse back into a singularity, potentially leading to another Big Bang in a cyclical process. This concept echoes ancient cosmologies and suggests that the universe may go through infinite cycles of birth, expansion, and rebirth. These cosmological theories don't just push the boundaries of physics, they also raise profound philosophical questions. For instance, if multiple universes exist with different physical laws, what does that mean for the nature of reality? How do we define existence when faced with an infinite multiverse? The famous physicist Stephen Hawking pondered these questions, noting in A Brief History of Time that, quote, "Our quest for discovery drives us to ever more profound questions, to which we may never find the answers." The potential existence of a multiverse also brings up the anthropic principle, which suggests that the universal's laws appear fine-tuned for life because only in such a universe could observers like us exist to notice it. If there are countless universes, each with different properties, it might not be surprising that at least one has the conditions suitable for life. Exploring these ideas further, the intersection of quantum mechanics and cosmology introduces even more intriguing possibilities. For example, the many worlds interpretation of quantum mechanics proposed by physicist Hugh Everett implies that all possible outcomes of quantum events actually occur in separate, branching universes. This means that there could be an enormous number of parallel universes where every conceivable history is realized. Advancements in technology are helping us probe these mysteries. The deployment of the James Webb Space Telescope, for instance, allows astronomers to look deeper into space and further back in time than ever before. By observing the earliest galaxies and cosmic structures, we can gather data that may support or refute these cosmological theories. As we contemplate these vast and complex ideas, it's important to reflect on the interconnectedness of scientific exploration and philosophical inquiry. Our efforts to understand the universe are not just about accumulating knowledge, but also about seeking meaning and context for our existence. The astronomer Carl Sagan eloquently expressed this sentiment in Pale Blue Dot, stating, "The Earth is a very small stage in a vast cosmic arena. Recognizing our place in the universe can inspire humility and a deeper appreciation for the shared journey of discovery." In addition, these theories have practical implications for other fields of research. For instance, understanding the fundamental nature of particles and forces could lead to new technologies, much like how quantum mechanics has given rise to semiconductors and modern electronics. Gravitational waves, first predicted by Einstein's theory of general relativity and recently observed by the LIGO experiment, open up a new way of observing cosmic events like black hole mergers and may offer insights into the early universe. Moreover, the study of dark matter and dark energy not only challenges our current models, but also drives innovation in detector technology and data analysis techniques. These endeavors demonstrate how pushing the boundaries of theoretical physics can have ripple effects across science and engineering. As we reach the end of today's exploration, it's clear that the quest to understand the origin and nature of the universe is both a scientific and a philosophical journey. Each theory, from the Big Bang and string theory to quantum fluctuations and the multiverse, adds a layer of depth to our understanding while also highlighting the vastness of what we have yet to comprehend. In the words of Nobel laureate Richard Feynman, "I think nature's imagination is so much greater than man's. She's never going to let us relax." This reminds us that the universe is full of wonders beyond our current imagination, and it's our responsibility to keep seeking, questioning, and learning. Thank you for joining me on this cosmic journey. Until next time, keep your eyes on the stars and your minds open to the boundless possibilities of the universe.